Hey, 7th graders. So I'm really excited to start a new unit with you guys today. So the focus for our new unit is going to be populations and resources. So mainly we're going to look at animal populations because we can influence them slightly less than just like a human population. But your guys' learning targets for today are I can model how to change the size of a population, and I can describe how births and deaths influence the size of a population. Okay, so we're really going to look at population sizes and how we can change those in this first lesson. Really, our next couple lessons will all be along that line. Okay. First things first, I want you guys to add some things to your notes. So we are starting a new unit, so you'll need to open your OneNote. You guys will need to go to Add Section and add a new section called Population and Resources. And then you don't have to worry about this community interactions yet, but I want you guys to add 2 new pages. Vocab and key concepts. Okay, once you guys have that done, you guys should be able to add today's vocab and key concepts in, which doesn't seem to be updating on my computer, but it is there. Okay, so unit question, why do populations change size in an ecosystem? So again, that's going to be our focus for this unit, are those factors that affect a population to either increase, decrease, or stay the same. And then your key concepts for today are within a population, organisms are always being born and dying. We're skipping key concept number 2. Key concept number 3, if the number of births and deaths in a given time are equal, then the population size will be stable. And finally, if there are more births than deaths in a given time, then the size of the population will increase. However, if there are more deaths than births in a given time, then the size of the population will decrease. Okay, and then your vocab words are population, a group of the same type of organism living in the same area. So if we're talking like a population of elk, we might look specifically in that area and we're just looking at elk. So maybe like Yellowstone National Park, how many elk are in that area? Because they might be more apt to intermingle. Okay, ecosystem are all the living and non-living things interacting in a particular area. So again, Yellowstone would be an example of an ecosystem. So not only are we looking at all the different living things like grasses, plants, trees, bacteria, fungus, animals, whatever the case. We're looking at all the living, but also all the non-living things. So one of the best non-living things that you have in an area is weather, because it really influences what living things you'll see there. So weather would be like a non-living thing. Landscape is a big non-living thing. Okay, so ecosystem is all the living and non-living things interacting in a particular area. And then finally, stability, when something stays mostly the same over time. So we're going to use this word mainly when we talk about population size. Are they stable and about staying the same, or are they increasing and decreasing? Okay, all right, moving on, I'll have you guys right click and watch this video in YouTube. It looks a little something like this. Focus for this unit, or our phenomenon for this unit, is talking about jellyfish populations. Okay, so this is kind of your amplify introduction to these jellyfish populations. One thing I don't like about this unit, though, is that it talks about a fictional place. So it talks about the glacial sea. Okay, not a thing. You won't find the glacial sea on a map. So we're going to use amplify a little bit for this, mainly the simulation and some other different articles that talk about just animal populations in general, which are all great. But as far as this fictional glacial sea, we're not going to concentrate too much on that place itself. But we are still going to talk about the populations that they refer to in this video. Simulation. This is going to be really quick for you guys. You're not really doing much in the simulation today. I want you guys to open it up. And the main thing you guys are going to do is you're just going to explore. Okay, so open the simulation, select 3 populations, intro. And then explore and pay attention to what does each button do, what can you change, and what data can you collect. Okay, here's some more simulations for you guys. So just kind of watch one individual organism and observe what happens to them. Okay, what kind of things it does, what things happen to it. And then you guys can watch a second organism and do the same to that. Okay, you guys will record your populations right here. So first organism, what kind of things did that organism do? And what kind of things happened to that organism? You guys can see some examples there. It ate other organisms or was eaten by other organisms. Okay, what's your second organism? What kind of things did it do? And what kind of things happened to it? So I'll kind of just show you really quick what that looks like. Of course, this is going to take a long time to load. You guys are going to choose the first one at any rate. Here we go. 3 populations intro. You guys are looking at 3 populations of green leaf, which is a type of plant. This wee bug, which is a little bug, and then this furbill, which is a little animal. Okay, so you're going to observe, kind of choose one of those. You can zoom in. Again, in your little playing with the sim, you guys should be able to find out all of these things too. So just watch one animal and see what kind of things happen to it and what kind of things it can do. Okay, again, you guys can zoom in a lot to kind of see a little bit more what might happen to your one organism. Okay? All right. Next activity is a little reading. So I'm going to read the first part to you guys. So here's your link to your article down here. Right-click and open your link. It'll take you into the library. So I'm going to read this introduction to you, and then I'm going to introduce you to all the different articles that you will pick 2 to read. They're all fairly short. So this is called Life in the Arctic. So first little picture here, the Arctic Ocean may be very cold, but it's filled with lots of different organisms. So at first glance, the Arctic Ocean might not look like a great place to live. After all, it's cold there. However, despite its year-round cold climate, the Arctic is full of life. The chilly Arctic waters are home to many different populations of organisms, from tiny algae to giant whales. To learn more about the populations that can make up an Arctic ecosystem like the Gulf of Alaska, read one or more of the following chapters. Okay, so you guys are going to choose 2. I'm going to have you guys choose 2 different ones. So if you guys look on this picture right here, you guys can see that I've taken a picture from the articles that each of the different articles there are and the organisms that it features. Notice that some are labeled 1. So I've got the moon jellies, the sea turtle, the orca, and the walleye. And then the other ones are labeled 2. So we've got, what was this one? A green urchin, algae, kelp, and zooplankton. Okay, so those are all labeled 2. So you guys need to pick one number 1 article. So either sea turtle, moon jelly, walleye pollock, or orca. And then you need to pick one number 2 article. So either the urchin, the zooplankton, the algae, or the kelp. Okay, so I'll show you those articles, or like I said, are pretty easy. So after you guys read the introduction, which I just read to you, you guys can click next. And you guys will see, all right, here's your moon jelly article. It's not very long, with 2-3 paragraphs each. You have walleye pollock. So again, all of these are pretty short, so I want you guys to pick 2. One from the larger animals and one from the smaller microorganisms or plants. Okay, algae, leatherback sea turtles, orca, which are killer whales, green sea urchins, and giant kelp. So those are your articles. Again, you'll pick 2 and read. Let me know which 2 you read by clicking on the draw feature and circling the 2. Oh, I read the sea urchin and the kelp. Okay, so you should have one number 1 article circled and one number 2 article circled. You guys are more than welcome to read more than that if you'd like. And don't forget that Amplify will read these to you also.
Chapter 9, Kelp.
Okay, all right, moving on. Activity 5 is a little hands-on. So obviously if you're in class, you're probably not watching this video to begin with, but you guys will be using little tokens for this. If you are at home, you guys are going to be using this little model right here, which I'll show you in a second. So what you guys are going to represent with these little tokens are the numbers of deaths and the numbers of births in a population. All right, so births and deaths are always happening in a population. How does the number of births and deaths in a population affect its size? To find out, try these 3 missions. So you're going to have 3 different missions to complete. 1, to keep your population the same. 2, to increase your population over time, and 3, to make this population decrease. So what you're going to have is 14 tokens out on a little circle, and then you're going to go through 6 rounds of this. So every year, you guys are either going to choose 1, 2, or 3 organisms to die, and 1, 2, or 3 organisms to be born. So then you're going to add those tokens accordingly. If you guys have 2 organisms being born, you're going to add 2 tokens to your circle. Okay, if you have 3 dying though, you're going to take 3 out of your circle. Okay, so to make an organism die, remove it from the population and add it back to the cup, or in this case, just the right side of your screen. and that's going to be 1 death. And then to make an organism be born, add 1 token from the cup to the circle, count this as 1 birth. Repeat until you have modeled 6 years. At the end of every year, record the number of births, deaths, and the organisms total on the chart, and then plot that number of organisms on the graph. At the end of 6 years, add up the total numbers of births and deaths and record it into the total column. Okay, so I'm going to go through this one first with you guys. So first of all, here's your guys' little circle. You have 14 little tokens in the circle, and you guys can click on those tokens to move them, okay? So notice how I can move those. And then over here, you guys kind of have your pool of tokens to represent whether you guys have given birth or had an organism die. Okay, so let's look at mission number 1. We're going to kind of do this together. So your mission is to make the population size stay the same over time. Okay, so that doesn't mean that absolutely every year you have the exact same number of births as deaths. But basically, if we were to look at our 6-year span, we're going to have about the same number in our population. It doesn't have to be exactly 14. It could be 15. It could be 13. That's still pretty close to 14. Okay? So we want it to be about the same. It doesn't have to be exactly the same. So you guys are going to choose a number from 1, 2, and 3. So for year 1, we're going to say, you know what? I want 2 births. Great. Okay, I want to have 3 deaths, however. Okay, so then I'm going to go up here and I'm going to say, all right, 2 were born. So I'm going to add 2 to my population. 1, 2, and 3 died. So I'm going to take 3 away. 1, 2, 3. It doesn't matter which ones you guys grab. Okay, at the end of that year, we're going to count the population. We started with 14. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have 13 left here. So I'm going to say organisms, 13. Okay? Then I'm going to go over here with my draw tool and I'm going to plot that number. So we're on year 1. We have 13 organisms. So I'm going to put a little dot right there and then I'm going to connect the dot. Okay? I'm going to do the same thing for slide 2. Remember when you use the draw tool to click back on your cursor? And I'm going to say, all right, this year I'm going to have 3 births, but only 1 death. You guys get to choose. It's just a number between 1 and 3. And I'm going to go model that with my slide up here. So I had 3 being born, so I'm going to add 3. 1, 2, and 3. And 1 death, so I'm going to remove 1. And then I'm going to go through and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this year I had 15. So I'm going to go draw 15 right here. And I'm going to connect that dot as best as I can. Okay? Again, your goal for mission 1 is to make your population size stay the same over time. Okay, again, that doesn't mean that exactly every year you have to have the exact same number of deaths as births and that it needs to stay at 14 every year. But overall, we want our kind of average for this to be in this 14 range. So we don't want to stray too far from that. We might bounce above and below a couple times, but we're going to end up either at 15, 14, or 13 by the end of this. Okay? So you guys are going to go ahead and keep totaling. All right, that year I had 15 organisms. At the end of this, you're going to total how many births you had over 6 years, how many deaths you had over 6 years, and what your final population is over this, okay? So you'll fill out the rest of this table, finish graphing right here. I'll kind of leave the first 2 done for you guys, okay? And then you guys can go ahead and finish the rest. Remember, your trend is to keep them around 14 for your total population, so about the same number as deaths and births. Doesn't have to be exact. Okay, your next one, I gave you guys another little one that's reset, so you guys are starting over again with 14 here. And you guys are going to do mission 2, which says make the population size increase over time. So over this 6-year period span, you guys should have more than 14 individuals in your population. So with that being said, I want you guys to really think about how many births and how many deaths you're going to have each year to end up somewhere higher. It doesn't necessarily have to be in this range, but higher than 14, okay, at the end of your 6-year period. All right, mission 3, again, very similar. I gave you guys another restart here, so you have 14 in your hole, and then a couple waiting for you guys to change your births and your deaths. And again, make the population decrease over time. So I'm going to let you guys figure that one out, okay? What needs to happen for you guys to decrease your population? Finally, complete your wrap-up. Do you have any questions? Circle yes or no. If you guys have any questions, type them in right there. Remember, if it's a question that's preventing you guys from finishing this assignment, you guys need to let me know right away so I can help you out. And finally, you are all done. Now turn it in because I am freezing in this Arctic environment. I hope you're all having a wonderful day, and I'll talk to you soon. Bye.